All right, today we are going to be talking about square roots. So we've already been talking about exponents in our last unit. Square root is the opposite of taking anything to the second power, or we also call that squaring. So I do want you to write this slide down, but it says a square root is the inverse operation, or the opposite, of squaring. So if 7 squared is 49, then the square root of 49 is 7. Okay? The reason I have this little symbol in front is because a positive and a negative 7 multiplied together would both be 49. So that's what that says here. Every positive number has a positive and a negative square root because, so an example here, 7 times 7 is 49, and negative 7 times negative 7 is also positive 49 because two negatives make a positive. So when you take the square root of something, it's positive 7 and negative 7. But instead of writing it out as two separate answers, we just put this plus or minus in front. All right? A perfect square is a number with integers as its square roots. If you've ever taken a look at our cabinets in our classroom, the first row are all perfect squares. And they're in squares because the term comes from finding the area of a square. The second row is perfect cubes, which we'll actually talk about tomorrow. But for example, 1 squared or 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. And so on. And it's really, if you know your times tables, this list is really easy to generate. But I think you should have 1 through 12 memorized. There are the most common ones. So here's 10, 11, and 12 squared. Okay, these are the most common ones. You'll be able to do your work a lot faster if you just know these 12. All right? So those are all perfect squares because they're whole numbers squared. So find the square root of the perfect square. So the square root of 36, we want to find what number times itself equals 36 would be positive and negative 6, because 6 times 6 is 36. Okay, and it's always going to be positive and negative for square roots. The square root of 100 is 10, positive and negative 10, because 10 times 10 is 100. The square root of 121 is positive and negative 11. 11 times 11 is 121. Now, not all of them are going to be perfect, and not all of them are going to be obvious. So the first three we didn't really need a calculator for. These 4, I'm going to show you how to use your calculator. So go ahead and grab one if you don't have one. All right, so here's our TI-30. And the square root button is above the squaring button. So this is what you would normally use to get an exponent of 2. The square root is right above that, this little green radical symbol. Okay, that's what it's called, a radical. So we would do second and then that button to get your square root. Then I'm going to go ahead and type in 9/16. That's what it asks for. And we get 3/4. Now it does not put the plus or minus on the screen for you. You have to remember to do that on your own. So positive and negative 3/4. Okay. Now let's do the square root of 2.25 is 1.5. So positive and negative 1.5, or 1 5/10. Okay, we'll repeat this process for 1/100th is 1/10. Positive and negative 1/10. And one more. Positive and negative 1.2. Now, some of these you might have been able to do without a calculator, like for instance this one, the square root of 9 is 3, the square root of 16 is 4. Decimals are a little bit trickier, but the square root of 225 is 15, so that's kind of where that one comes from. The square root of 1 is 1, the square root of 100 is 10, the square root of 144 is 12, so that's kind of where that one comes from also. But I think for decimals, it's kind of hard to figure out where your decimal point will be all the time. So I always like to go ahead and type those ones in. All right, evaluate the expression. So we have to do order of operations. Roots fall under the category of exponents. So in PEMDAS, it goes under E. So I don't have any parentheses, but then I'm going to do my exponent, the square root of 25. So the square root of 25 is positive and negative 5, but when you're doing something like this, it just wants the positive root. So you do 3 times 5. 12, 3 times 5 is 15. 12 minus 15 is negative 3. So this would be our final answer. Okay. For my square root, let's go ahead and type this one in. Second square root of 28 sevenths is 2. 2 plus 2.4 is 4.4. All right, just like we wrote in our notes, squaring and square roots are opposites. So we can type this in if you want. In fact, let's go ahead and do that. We'll do the square root of 4 squared. Okay, that's what this says. And you could add the parentheses. It's just going to be 4. Since these are opposites, they're going to cancel out. Okay, and then you just have 15 minus 4. If you forget they cancel out, though, go ahead and type it in. It'll tell you. Okay? All right, moving on. Solve x squared equals 81. To get rid of a square root, to get rid of a square, you square root because they're opposites. So if I want to get rid of this to solve for x, I need to square root both sides. So now these are gone. Okay, just like how we did this here, and it was just 4, now this is just x. The square root of 81 is positive and negative 9. Okay? Now, we want to get x squared by itself before we square root. Square root is one of the last things we want to do. So for this example, I want to get rid of this 3 first. These are connected by multiplication, so I'm going to divide by 3 on both sides. And then you have x squared equals 16. To get rid of this square, I'm going to square root both sides. And we get x equals positive and negative 4. All right, same thing here. The first thing I'm going to do is divide by 7, which gives you x squared equals 25. Then I'm going to square root, which will give me just x. So don't write x squared anymore now. It's just x is positive and negative 5. This last one is a 2-step. So I'm going to first add 6 to both sides because you do your addition or subtraction first. So this would be 196. Then I'm going to divide by 4 on both sides. So you have x squared equals, I'll type that in over here, is 49. And then lastly, you'll square root So now you just have x equals positive and negative 7. Okay. The area of a crop circle is 45,216 feet. What is the radius of the crop circle? On your homework assignment, I give you the formulas at the end in parentheses. So the area of a circle is pi times radius squared. Okay? So here they're telling us our area is this 45,216. So I'm going to plug that in. Now pi is a number, so I'm going to divide by pi on both sides. I'm going to pull that calculator back out. And then divide by pi. Your pi button's right here on your calculator. Okay, we'll round this to just one decimal place. So we have 14,392.7 is approximately r squared. So when I round, I switch from a regular equal to our wavy equal. And then to get r by itself, I'm just going to want to square root both sides. So I'm going to square root and I get 119. We'll actually just round this up to 120. So 120 feet is approximately our radius. Okay, we rounded it, so it's not exactly, but pretty close. All right. So on these, it's just like this type of problem, but we've put it in some context. And again, on your homework, look for the formulas. I put them on there for you, and some of them I even started for you. At this point, you're finished with your notes, so you can raise your hand and show me them to get your worksheet.